So example 23. A piece of A4 paper is folded in half repeatedly. The thickness of the A4 paper is 0.5 millimeters. So A4 folded in half repeatedly. The thickness of the A4 paper is 0.5 millimeters. Work out the thickness of the paper after 4 folds. Okay, well, let's have a little think about that. So if we think U1, so our starting thickness, is equal to 0.5. As I said to you before, with these kind of questions, it's always good to start with a few terms. So U1. Now, when I fold that in half, that is going to be twice as thick, isn't it? Yeah? Twice as thick. So when we get to the next term, if we fold something that was 1 millimeter thick in half, it would now be 2. Again, we've multiplied by 2. Meant to write that in red. Multiplied by 2. So to get to 4 folds, multiply by 2 again. U4 equals 4. Now, you might think we've finished at U4, but if we were counting the folds, count folds, that's 1, that's 2, that's 3. So if we got to find 4 folds, we're going to have U5 is equal to 8. So we need to think about how we number these carefully. To find a general rule. So for part B, we don't really want to write out the whole thing. And we know it's going to be UN equals A lots of R to the n minus 1 is our nth term generally. Does that fit with our sequence? So if I take off 5, so if we say n equals 5, so n is equal to 5, subtract 1, will give us 4 folds. So that looks like it works quite nicely. Sometimes you have to play around with this to make the data fit the context that you're given. So sometimes you end up using UN equals A R to the n. It just depends on how you set it up at the start. So if I'd used the folds as my term, so if I'd had U1 equals 1, because I've done 1 fold, my equation down the end then here would be UN is equal to AR to the n. So all I'm saying here really is look at the context, think about how you define the suffix, these ones, yeah, right? If it had it as the n being the number of folds rather than, if you like, the number of thicknesses that we'd had. I hope that's clear, but all I'm really trying to get at is think carefully. There's some decisions to be made around whether you're using AR to the n minus 1 or AR to the n, depending on the context. But here, we're okay to use AR to the n minus 1, which is our learnt standard result. So, U20 then is equal to A, which was 0.5, times R, which is 2, because we're multiplying by 2, times 20 minus 1 to the power 20 minus 1. So that ends up being the same as 2 to the 19 times a half, which is 2 to the power 18. So we're going to get up close to 1 million. AR to the n minus 1, let's just check, that's right. I think the textbook's wrong here. So we've got 20 minus 1. So we get tap it in the calculator, and the book is wrong. They've got 0.5 times 2 to the 20. Well, I think that's like 2 to the 19, but we've got it as 2 to the 18, which is 524288 divided by 2. So that's going to be 2 2 6 2144 millimeters. Pretty sure that's correct, even though the book has got a different answer, because we've identified that 4 folds gives 8, so I know that I've got the AR to the n minus 1. I don't think that they've thought about it carefully when they've done their answer. Okay, so we're going to carry on from there. Now, what does it say? Work out the thickness of the paper after 20 folds. Hang on, 20 folds. So 20 folds that means to have done 20 folds, I've made the mistake. So when I get to U20, I will have only done 19 folds, haven't I? So I actually need, sorry, my mistake. So I need U21 in there and 21 there minus 1, because I need to have got to position 21 to have done 20 folds. Need position 21 to have done 20 folds. So it does depend on how you set it up. Okay, so that will make that 19, my mistake, which will give the answer which is in the book, which is 524288, which is 500,000 roughly, because I know 2 to the 20 is just over 1 million. Okay, so that is now correct. Part C, millimeters. Well, that's pretty thick, yeah? So state one reason why this might be an unrealistic model. It's impossible to fold the paper that many times. It is impossible to fold the paper that many times. Okay, because let's face it, that's going to be over 500 meters, yeah, which is just ridiculous. Okay.